Alrighty, today we're going to be having a look at Pythagoras in 3 dimensions. And you can see I've got this box here with 48 centimeters across, 12 centimeters deep, and 16 centimeters high. And the question that we want to answer is, what's the biggest straight long pole that we could fit between A and G? So we're interested in what is the largest sort of thing that we can fit. Just to kind of give us a little bit of a picture, you can imagine putting a pole right through from one corner to the other. It could be any of these. It could be from C to E. It could be any of these. And the question is, how long is that pole? Now, in order to work out the length of the pole, we're going to need to work backwards a little bit. Now, just as like a little bit of a reminder, all of these sides are the same length, as are all of these sides the same length, as are all of these lines the same length as well. Okay? So just as kind of like a reminder of that fact. You can always remember that parallel lines going in the same direction, are going to be the same length or related to each other in most right angle shapes. So let's imagine first that we want to find AG. So we're going to say that AG is going to be the goal. So that's this to this corner, the far corner, AG. Alrighty. Well, that's a right angle triangle. In fact, let's draw out that right angle triangle. Well, we're going to have A connects up to G. That's the one we're interested in. And then we're going to have G to H, and we're going to also have A to H. Alrighty. So we know that this is A, G, and H. There's like a cross section of this. We know this is 16. This is what we want. And unfortunately, we also don't know this one, so we actually don't know AH yet. So, sub-problem. Let's find AH. Let me get a red pen. AH is this length here to this length here. Well, that's also part of a right angle triangle. Let's draw out that right angle triangle. So that right angle triangle is going to be A to H, once again is the hypotenuse, H down to E, and then E across to A. So A, E, H. Now EH we know is 12 centimeters, and AE is 48 centimeters. So we can work out the third side. So in order to find AH, this side, let's call it X, well, I need to find out I need to find AH before I can find out AG. Alright? So hopefully some of you can see this relationship here. So let's ignore this big annoying box and let's just look at these two triangles. The one on the right is solvable, so let's do that one first. C squared equals A squared plus B squared. And in particular we have C, let me turn off my straight line, C, A, and B, and we get C, we don't know C, so A is equal to 12, B is equal to 48, and we get C squared is equal to 12 squared plus 48 squared, and this is equal to 2,448, which the square root of that is some horrific number. So C is equal to the square root of 49.477. The square root of 2,448 is equal to 49.4772, which will round down to 477. I want 2 decimal places at the end, so I'm going to round to 3 decimal places throughout, and then at the end I'll wrap around. So we now know what this length is. This length is 49.477. That is the length of AH. But that's also the length down here, 49.4977. 477, sorry. Can't even read my own handwriting. Is the length of this triangle, which we now have enough information, A, B, and C, to solve. So let's now use Pythagoras' theorem again. And we get, A is equal to 16, B is equal to 49.477, and we get c squared is equal to 16 squared plus 49.477 squared. That's horrible. Let's just take the square root of that. 16 squared plus 49.477 squared, and that's equal to, and we get 51.9997, which is going to round up to 52.00 centimeters. And there we go. So in order to find the length of a pole that fits diagonally in a box, the longest pole, well, you need to work out its shadow, that AH length, and then you can work it out. Alrighty. 2 lots of Pythagoras theorem and 1 question. I'll see you in the next one. Goodbye.